So at 10 o'clock, the boat has left Victoria and it is 1 mile due south of Point Victoria Lighthouse. So on this scale here, each one of these is 1 nautical mile. That's 1 minute of latitude. And Point Victoria Lighthouse is here due south. We can eyeball. We'll say we're right here. We'll draw a circle with a dot in it and write 10 o'clock next to it. So that's our fix. A fix is a position at a given time. If we did want to use one of these to accurately do 180 degrees, we could just use the straight edges for that one. It's a very easy one, but we have the directional bearing from Point Victoria there. Keep one leg on the plotter, and then line up that grid there with the edge of the grid on the box, and that gives us our due south there. But there's no real need to do that that short distance. So at 10 o'clock, plot the position, mark the wreck as a waypoint. So the wreck is given as 46 degrees 27 minutes decimal 1. So each of these is 0.2, so decimal 1 is there. And the longitude is given as 006 degrees 23 decimal 2. So again, each of those is 2. So that's there. So we can see that there's a bit of a line there. It says to mark the wreck as a waypoint. You can see the wreck there. It's a wreck, depth unknown, not considered dangerous to navigation. So we found it using the latitude and longitude, and we can see the symbol for it there. So perhaps this is a dive expedition and they're taking a rib out to find the wreck, and they want to know what the course to steer is and what point to stop the boat so they can start looking for the wreck underneath them. So the next thing we're going to do is plot the course over the ground. Now, with the course to steer, we want to plot from the start to the waypoint. Draw a line through it as well. So you see the line goes all the way through it. Just gives you a little bit of extra room. So this is our intended ground track. So I'm going to mark that with 2 arrows. During this time, the tide was flowing at 340 degrees true at a rate of 2 knots. So that's a known quantity that we can put at the start of our tidal vector there. So if we dial in 340 on the plotter and put one leg of the divider on our start position, then rotate the plotter until the grid lines up with the lines of latitude and longitude on the chart. So I've got a couple there. I've got one there and I've got one there that lines up. Oh, and I've got one here as well. So we've got a few of those. So that's definitely a line of 340 degrees true. So we're going to draw that, and it's going to be 2 nautical miles long because the rate of the tide is 2 knots. And we figure that this whole journey will take approximately an hour based on our boat speed and our distance to the waypoint. Just like to nip the end of those tidal vectors off so that you don't accidentally go from the end of where you've drawn to. This is the tide, so we'll mark that with 3 arrows. Marking it a bit heavier than I would actually do chart work normally, just so you can see what's going on. Using our boat speed of 6 knots, we measure 6 knots from the side, the latitude scale, near to where we're operating. So I've got 6 knots, 6 miles that the boat will travel in 1 hour. Perhaps let's mention more. And one leg goes on the end of the tidal vector. So we never join this up to the waypoint. We join it to what we call the scribe mark. You can imagine scratching that end of the divider through there and making a curve there, which you could call point D if you were using the Reed's methodology. And we connect the end of our ground track here to the scribe mark, and that's our course to steer. That's a water track, so we measure that. We mark that with one arrow and measure it using the edge of our plotter there. North aligned with north, and reading that off from where the 0 is, we have 256 degrees true.